Chemistry is the scientific study of matter, and in chapter 1 we're going to look at the scientific method, and then we'll look at matter and measurements. Now it turns out that the scientific method relies on the integrity of the person performing the measurement. And all that science is a method of observation. It's a method of observation that allows you to test your findings. And it's really important that the observations lead to something that you might be able to spot a trend in, and then after that trend you come up with some kind of theory that then can be testable. It's important that you find enough pieces of information, of data, that will exclude anomalies from popping up from time to time. And it's important that the trends come after you have made the observations. It is not good science to have something in mind and then go seek the information that props up your idea. That's not what science is about. The data should lead to a trend, the trend should lead to a test, and ultimately our scientific theories need to be testable and, importantly, reproducible. One of the big problems in the scientific method is that humans themselves are notoriously unreliable. I'm going to show you now a little YouTube video that is an awareness test.
This is an awareness test. How many passes does the team in white make? The answer is 13. But did you see the moonwalking bear?
That's actually a British public service announcement for cyclist awareness, because drivers, when they're looking for cars,
all right, so imagine you're flying.
expect to see cars.
But wait a minute.
And of course,
Where's the airplane?
when they see
A
something that's not a car, they don't really see it. All right, so humans, good at observations? Not necessarily. Here's a very, very simple task. Count the number of times that the letter F appears in this passage. Finished files are the result of years of scientific study combined with the experience of years. It's kind of an odd thing to say. It's kind of clunky, but all you have to do is count the number of times that the letter F appears in that passage. Take a second, think of your answer, and I wouldn't be surprised, and you shouldn't be surprised either, if your answer is not 6. The human brain, by the time you've learned to read and be in college for all of these years, is tired of reading the small words, and so while you think you are reading a passage, your brain is not really reading it. It skips over all the small words, the ifs, the ands, the thes of the passage, and your brain doesn't actually pick them up. Cognitive science will tell us that if we want to perform this task, we should read the passage backwards so that we don't get the inherent bias that our brain is enforcing on our world to come into play. So one of the really important pillars of the scientific method is that our work be reproducible. And in scientific research, the pinnacle here is peer review. So when we find a new discovery, we write that up as comprehensively as we possibly can, and we give it to the world, and then we have other people from all around the world see if they can reproduce our results. And if people who are not associated with the original work can get the same results that you did, then your findings are valid. There is also something associated here that we don't deal in conjecture. There are things that are outside the scope of science, and we should be comfortable with that. And that if you assert your theory, but your theory has no evidence to back it up, then I should not have to pay that any mind at all. I can dismiss that one out of hand. How many times do you think you would have to reproduce a small task in order to actually physically demonstrate mastery of that task? If I told you that I could play the piano, how many keys do you think I should have to play? If I say I can play the piano and just press the key once and you hear one note, is that enough to convince you? If I tell you that I can predict whether the next card in a pack of cards is a red card or a black card, how many times in a row should I be able to do that without error? And in data science, in numeric science, we're looking for 99.5% predictability. So only a 0.5% possibility that you came to that answer by chance. One of the great things about falsifiability, about the scientific method, is this thing called falsifiability. It means that you cannot prove anything to be true. No scientific theory is ever true. Outside of mathematics, where there is actually a proof, 2 and 2 does equal 4, all that we do in most of the physical sciences is build to a more complete answer of what the universe is doing. And so if I just continuously add more positive data to my pool of evidence, that does not necessarily mean that I am proving my argument to be true. In fact, all I would need is one contrary piece of evidence to prove that my theory is incorrect. And this is a wonderful thing. It means that scientists are not really completely embedded, entrenched in their ideas, that we continuously are told that a new improved model of the universe, and we change our minds and we evolve with the method. And this building a knowledge base that gives a complete or a more complete understanding of the problem is called a paradigm. Paradigm is just the best available explanation of the situation at the current time. And paradigms change. It used to be thought that the Earth was the center of the universe, and you go out and you do the observations, you clearly see the sun come overhead and go down at nighttime. And you can do those observations over and over and over again, and it's clear from your observation that the sun is going around the Earth, and it isn't later until you do another kind of observation from a different vantage point that you realize, no, the Earth actually goes around the sun, and in fact, not even in a circular orbit, in an elliptical orbit, and we shift the paradigm. And sometimes the paradigm shift is incredibly important, and it has not only just scientific implications, it has political implications as well. And then sometimes the paradigm changes, and it's so completely unimportant that nobody bothers to adopt it. Case in point, which of these fruits is a berry? The strawberry, the raspberry, the blackberry, or the banana? The answer is the banana. Out of all of these four, the banana is the only fruit on the board that is a berry, because the encyclopedia definition of a berry is a fruit whose seeds are evenly distributed amongst the flesh of the fruit. And that's the only one that's true, because blackberries, strawberries, and raspberries have their seeds on the outside of the fruit, and therefore don't meet the encyclopedia definition, and yet we still retain them as berries. So sometimes a paradigm that our collective body of knowledge must change when something new comes along, and sometimes people are slow.